Okay, in this video, I'm going to show you how to do each of the questions on the practice quiz for Chapter 5. For all of the graphs, you need to find 4 values. The first one is the HK value, which is everything after the X. So we have 0, 0. Then you have the A value. The A value is the number in front of the number with the exponent attached to it. So the exponent number is B, that's 4. And the A value is -1. The last thing you have to find is the asymptote. And the asymptote is always going to be the y for exponential functions equal to that number, which is the k value. So y is equal to 0 is the asymptote. So the HK, I'm going to go ahead and draw that in even though it's on 0, 0. Just so we could follow the same format on all the problems. Then we're going to make an XY chart. In the XY chart, we're going to pick 0, 1, 2, 3, -1, -2. You might need -3. You need to at least have 2 numbers above and below to start with until you figure out what's happening in the problem. So the A value is the initial value. That's going to tell you where you start on the 0. So that would be at -1. The B value is the multiplier. So as you're moving, you're multiplying by 4. So 1 times 4, -1 times 4 is -4. -4 times 4, -16 times 4. Obviously, the numbers are getting pretty big. They're not going to be on the graph. You don't really have to go down to -64. And then on the way up, you're dividing by 4. So -1 divided by 4, and then -1/4 divided by 4. And you're welcome to use decimals there. I find it easier to use fractions. So we plot the points. So we go to 0, -1. Then we go to 1, -4. The next point would be 2, -16. So that'd be -10, 11, 12, 13, 14, 15, 16. You can kind of guess to see where it's going to be. You don't have to extend your graph that far, but at least you'll know where the graph is pointing towards. On the back end, it's -1, and then -1/4, and then -2, -1/16. You cannot cross this line because that's your asymptote. Okay, so we're going to draw this graph, and we're going to extend it, curve it, and then I'm going to go ahead and extend it all the way down to this. And make sure that there's no space here when you draw this line because it's getting closer, 4 times closer every single time. And that's it for number 1. For number 2, you're going to have the HK, which is everything after the X. So it's going to be 1, -2. You always do the opposite of the H value. The A value is 2. The B value is 3. So this is A, this is B. Over here, this was A and that was B. And then the asymptote is y equals -2, which is, again, that number. So we go to 1, -2. And that's our new origin. This line right here that I'm drawing first, that's the line that you cannot cross, which is the horizontal line. So making the XY chart, again, 0, 1, 2, -1, -2. We start at the A value, which is 2. That's 0, 2. And then the multiplier is 3. So 2 times 3, then 6 times 3, 2 divided by 3, and then divided by 3 again. Again, you can use decimals there. I believe it's 0.6 repeating and then 0.2 repeating. When you graph these points, you're graphing them the 0, 2 as if this was your origin. So we go 0, 2, and then we go 1, 6. So 1, 1, 2, 3, 4, 5, 6. The next one's going to be off the graph, but let's just see. So we have 2, and then that's going to be 12, 13, 14, 15, 16, 17, 18. So it's way up there. This is going to be negative 1 is at 2/3. Negative 2 is like at 0.2. So this is your graph. Again, you cannot cross that line. And then I'm just going to draw an arrow pointing up to that point up here. And again, no space here, and don't cross the line. Because if you were to cross the line, you're saying that these numbers somehow become negative, and they don't. Okay, same thing here. If you cross this line, all the numbers are negative, and they never at any point become positive. All right. Next, for the next graph, we have the HK is going to be 0, -3. And the reason it's not 3, 0 is because H is part of the exponent. And so since we don't have an exponent there, then you don't have an H value, or the H value is 0. For the A value, it's 2/5. If you put that in a calculator, that's equal to 0.4. So you can do it that way. If you, the B value is E. Since you have to put it in your calculator as E to the first, then I'm going to go ahead and put it in as E to the first as well. And the HK, or excuse me, not the HK, the asymptote is going to be Y equals -3. The XY chart is going to be 0, 1, 2, 3. Sorry for the delay. I'm like looking at trying to find the answers for the E value, so because I don't have a calculator. -1, -2, this is 0.4. Then our multiplier is E to the first. So we're going to multiply that by E to the first power, which gives you 1.1. Then we're going to multiply again by E to the first power, which gives you 3.0 if you're rounding. And then we'll multiply by E to the first again, which would give me 8.0. This way I'm going to divide by E to the first, which would give me 0.15. I don't really need a number smaller than that. So I'm going to go ahead and draw in the HK at 0, -3. You don't have to draw the one that's on the y-axis. I just think it's helpful. When I go to plot these points, I plot this first point from this new origin, so 0.4. The next one, 1, and then 1.1, and then 2, and then 1, 2, 3, and then 3, and then 1, 2, 3, 4, 5, 6, 7, 8. You can do the next one if you want. It'll be 16 or 17 point something, somewhere around that. It'll definitely be off the graph. This is 0.15, and then go ahead and draw that in. I don't have the numbers in front of me. I should have probably found the next point here. For number 4, the HK is everything after the X. So that's a -1, -4. The A value, since there isn't one, is 1. The B value is 1/3, and the asymptote is Y equals -4. For my XY chart, 0, 1, 2, 3, and then -1, -2. The A value is 1, so that's here. Then the multiplier is 1/3, so I'm multiplying by 1/3, multiplying by 1/3 again, that makes a 1/9. And then dividing by 1/3, which is the same thing as multiplying by 3. So that gives you 3 and 9. I'm going to go ahead and draw the HK here. So if I draw in the HK, where is that? -1, -4. If you have different colors for the test, it'll definitely be helpful. Then 0, 1 from this new origin. 1 is then it's 1/3, and then 1/9. And if I go -1, 1, 2, 3, -2, 1, 2, 3, 4, 5, 6, 7, 8, 9. The next one would be 27, so it's going to be definitely off the graph. And those are the first graphs. Those are the exponential graphs. Most likely I'm going to provide a place for you to write these values, the first 4 values, the A, the B, the asymptote, and then the HK. So it's easier to find. For the money problems, so it asks you to find the balance, and the balance is the A value. So A equals, P is the principal, which means the amount you start with, so 12,500, times 1 plus R. R is the interest rate. The interest rate is 4.8%. You have to divide that by 100. That gives you 0.048. Divided by N. N is how often they give you your interest. So the interest is compounded weekly. There are 52 weeks in a year, so this will be 52. The NT means N times T multiplied together. So T is a time period. In this problem, the time period is 10. So if you multiply N times T together, you get 520. Okay, so NT is 520, and that's the exponent. When you put this in your calculator, you do all the stuff in here first. So I would do the fraction first, 0.04548 divided by 52 equals, I would add 1, raise it to the 520th power, and then multiply that result by 12,500. When you write your answer, it's going to be $20,196.46. For number 6, you're going to do the same thing. So again, we're finding the balance, which is A. You put 10,500 in the bank. The interest rate in this case is 3.35%, which is 0.0335. N is compounded monthly, so that means that N is equal to 12 for 14 years, so T is equal to 14. So 12 times 14 is 168, and that's the exponent. Again, do all the stuff in the parentheses first, raise that answer to the 168th power, and then multiply by 10,500. This will give you $16,772.18. Okay, continuing on the Chapter 5 practice quiz on the second page. For number 7, the interest is compounded continuously. And when the interest is compounded continuously, there's a different formula. That formula is A is equal to the principal times E, the value E, to the RT power. So again, they want us to find the amount in the account. So that's the balance. So we're finding A. When you write your formula, make sure you put A equals P, the number that you've put into the bank, deposited, the initial value, the principal value is 43.80. The interest rate is 0.054. The time that it's in the bank is 18 years. Okay. And if you multiply R times T, 0.054 times 18, you get 0.972. That's the exponent of E. So when you put that in your calculator, you're going to raise E to the 0.972 power. It's generally easier to do that exponent first. And then once you get that result, you multiply that by 4,380. That answer will be 11,000. Don't forget the dollar sign. $577.33. For number 8 and 9, you're graphing logarithms. So just like the exponential functions, you need to write the A, B values, the HK, and the asymptote. But there's one additional thing that you must write, which is you need to change the log function into an exponential function. So first, we're going to do the HK for both of them. Okay, I'm going to go ahead and just do both at the same time. So the HK for this one is -2, 0. And for number 9, the HK is 0, -3. If you notice, when it's in the parentheses, that's the H value, and you do need to change that sign. When it's outside of the parentheses, it's the K value. And so you don't have to change that sign. You use whatever's there. So I'm going to go ahead and plot that, or -2, 0, and draw in the HK. Okay, so we have HK. And in this one, it's -3, 0. For log functions, it's the vertical line that cannot be crossed. It's the vertical line that's the asymptote. So the asymptote for this is x equals -2, and this one is going to be x equals 0. So it's this line here. Okay, that's a line that will not be able to be crossed. Second thing is we're going to rewrite this by doing the wheel into exponential form. So that's 3 to the y power is equal to x, that exponential form. And this one is 1/2 to the y is equal to x. Make sure you put 1/2 in parentheses to indicate that the exponent applies to both the 1 and the 2. Now that it's in exponential form, you can write your a and your b values. So the a value is 1 and the b value is 3. When there is no a value, like it's like a 1 in front, it's understood to be a 1. Okay, the 3 is definitely the b value because that's where the exponent is part of the 3. It's 3 to the y power. So in this case, the a value is 1 and the b value is 1/2. And those have the same effect as when we did exponential functions. We have the initial value and then the multiplier. When you make your XY chart for log functions, you're going to put the 0, 1, 2, 3 on the y side, because the y is where the exponent is. And that's how you know the exponent is the y. So that's where the 0, 1, 2, 3 go. -1, -2, -3 if necessary. All right, the initial value is a is equal to 1. The multiplier is 3, so I'm going to multiply by 3, multiply by 3 again, and then multiply by 3 again. And then I'm going to divide by 3. So divide by 3, 1/3, and then 1/9. When you plot these points, again, 1, 0, from here, you go 1 zeros here, then 3, 1, 1, 2, 3, 1, and then 9, 2. So 1, 2, 5, 6, 7, 8, 9, 1, 2. And then 1/3, -1, 1/9. So when you draw this graph, logarithmic graphs are inverses of exponentials. And since they're inverses, the x's and the y's basically are reversed. And this one goes sideways. For number 9, the initial value is, again, 1. And then the multiplier is 1/2. So you're multiplying by 1/2. So that's 1/2. Multiply by 1/2 again. That's 1/4. I don't really need to go smaller. On the way back, you're dividing by 1/2, which is multiplying by 2. So that's 2, 4, and then 8. So multiply by 2. I didn't really leave myself enough room here, so I'm going to make a little bit more room. So then again, 2, 4, 8. Because you're going to multiply by 2, multiply by 2, multiply by 2. So I have 1, 0. Then I have 1/2, 1. And then 1/4, 2. I have 2, -1. 4, -2. And then 5, 6, 7, 8. And then -3. The next one will be 16. So We can't cross this line. It's rounded, and you make sure you extend your graph and put arrows on it. For number 10, we're going to apply that 3. So it's going to be negative 5 to the third, and then it's going to be e to the negative 2x to the third. Negative 5 to the third is negative 125. This will be e to the negative 6x. The negative 125 stays where it is, but because the e has a negative exponent, we need to move it to the denominator. So negative 125 over e to the 6x. Again, the 125 does not move to the denominator because it is not an exponent. For number 11, the negative 4 applies to the 3 and that. So we have 3 to the negative 4, e to the positive 8, because when you multiply the two negatives, you get a positive 8, over e to the 5th. The 3 to the 4th must move to the denominator. And then the e to the 8th and the e to the 5th, when you reduce that, it becomes e to the 3rd, but that's in the numerator because you have more e's at the top. And to simplify that, it's e to the 3rd over 81. For number 12, you take the 4th root of 81, so that's 3. And then you take the 4th root of e to the 16x. When you do that part, it's going to be e to the 16x divided by 4. So you divide the exponent by the root. That gives you e to the 4x. So I get 3 e to the 4x. For number 13, we're going to solve these. It says without using a calculator. Yes, I know you're going to have your calculator, but you need to show the work. So you need to show at least one step. So we're going to make these equal to x. Then we're going to do the wheel, or change it into exponential form. So 4 to the x is equal to 1. This one, mathematically, there's not really any way to do it, to figure it out, except for to know that the only way to get a 1 is for that exponent to be a 0. So for number 13, x equals 0. For number 14, we get 1/2 in parentheses to the x is equal to 8. Now, some of you might already know the answer, but you're trying to figure out what power do I raise 2 to get to 8, and then also flip it over and make it a reciprocal. So if you think of 1/2 as 2 to the negative 1, and you think of 8 as 2 to the 3rd, then you can solve it by just canceling those 2's out, and you get negative 1x equals 3, so x equals negative 3. You can, again, just do that part in your head, and I'm be okay with that. 1/2 to the negative 3 is equal to 8. For number 15, 9 to the x is equal to 81. You should all know that that answer will be a 2. And then for number 16, 5 to the x is equal to 1 over 625. 625 is 5 to the 4th, which is 5 to the negative 4 if you want to write it as just a 5. So x is equal to negative 4. Continuing this video, we're going to do the last page of the Chapter 5 quiz review. For inverse functions, there are a few steps. So the first thing you have to do for inverse functions is just remember also that if it starts off in logarithmic form, like 17 and 19, your final answer will not have a log in it. For 18 and 20, it starts off in exponential form, so it's going to end up in log form. We're going to switch formats. So the first thing you do is you switch the x and the y values. So you rewrite this exactly how it is, but the x and the y get switched. The second thing you do is you get whatever the logarithm is, you have to get it isolated, which right now it is. If it was an exponential, same thing. So now we have the logarithm isolated. You cannot move the 3 over because it's part of the logarithm. So now we're going to change it into exponential form. In order to do that, I'm going to do the wheel. So it's 6, that's the base of the logarithm, so it's the base of your exponent. The exponent is always whatever is on the other side of the log, so that's the exponent, and then that equals y minus 3. The last thing we have to do here is solve for y, so we have to add 3 to both sides. You cannot add the 3 to the 6, so it's 6 to the x plus 3 is equal to y. If you want to write the y first, you can. I'm going to go ahead and leave it on the right side. 6 to the x plus 3 is equal to y. For number 18, again, we're going to switch the x and the y. That's always the first step. In this case, I need to get that exponent isolated. So I need to move that 2 over so that the part that has the exponent on it is by itself. So I have x minus 2 is equal to e to the y power. Now that's isolated. Now I can switch it into the other format, which is log form. So in order to do that, I usually just write log equals and leave some space. The base of the exponent is e, so that will be the base of your logarithm. The answer to the log, or the opposite side of the logarithm, is the exponent. So this will be a y. That leaves only one other place for this to go, which is in front of the log, so that's x minus 2. Now, I've already solved for y, but you can't leave log base e in your problem. Log base e is the same thing as writing natural log. Okay, so any logarithm has a base of e is a natural log. So that's ln. So natural log of x minus 2. So we're taking the natural log of all of this. Don't lose the parentheses. The parentheses must be there. Is equal to y. For number 19, change the x and the y. That should be a step that everybody can do. Now we need to get the natural log by itself to isolate it. So I'm going to move the 4 over first by adding it over. It will become x plus 4 equals 3 times the natural log of y. Since that's 3 times the natural log of y, I need to divide that to get rid of it. So now I have the natural log of y is equal to x plus 4 over 3. The last thing now I need to do is to change that into exponential form because it's in log form. So every logarithm has a base, even if it's not there. We just finished going over it in number 18. So if it's a natural log, it has a base of e. So the base will be the base of the exponent. The exponent will be x plus 4 over 3, and then that's going to equal y. Okay, so we have e to the x plus 4 over 3. You need to make sure that it looks like an exponent, so if you have to raise it up a little bit more, do that, please. For number 20, I'm going to switch the x and the y. Then, I always forget the x. Switch the x and the y. Then we need to get the exponential part isolated. So this whole thing is the exponential part. We got to get rid of that 1/2, so we're going to multiply both sides by 2. This 2 and this 1/2 will cancel out, so I'm going to get 2x is equal to 3 to the y minus 4 power. Now that's isolated. You cannot add 4 because it's part of the exponent. So I'm going to change it into log form. Log equals. The base of the exponent is 3, so that's the base of the logarithm. The exponent is the answer to the logarithm, so that's on the opposite side. And then the 2x would go here. I can't have the 4 on the same side of the y because we're solving for y, so we're going to add the 4 over. I'm just going to go ahead and put it in the answer. So you're going to have log base 3, the 3 is a subscript of 2x. 2x is also on the line. And then plus 4, because we're moving, remember, adding 4 to both sides here. And then that equals y. Those are the inverse functions. For 21, through 23, if the base of the logarithm and the base of the exponent are the same number, they can be crossed off. So that's just -3. Natural log and e have the same base. E is the base of natural log, so you can cross those out. Here they don't have the same base, so I have to take the 81 and I have to change it into 3 to the 4th. Don't forget that you still have an x here, so that has to be brought down. So now I can cancel out the log base 3 and the 3, and I'm left with 4x as the answer. That is not 4 to the x, it's just 4x. 24, 25, and 26, those are just numbers that you're going to put in the calculator. 3 decimal places means 3 numbers after the decimal. So for number 24, it's 1.544. You're just putting log of 35 in your calculator. For 25, it's 0.588. And make sure you round correctly. And for 26, it's 2. It's exactly 2. There's no rounding there. The last 4, you're just changing formats. You are not simplifying or changing anything else, just the format. So for number 27, you're going to have 9 to the 5/2 power, so raise that up to make sure it looks like an exponent, is equal to 243. Again, 9 is the base. That's the power. This one's the exponent. And then it's equal to 243. Okay. For number 28, it's 1/2 in parentheses. This is the exponent, and it equals 32. 1/2 in parentheses to the -5 is equal to 32. And then the last 2, you're changing it back to log form. So the base of the exponent is 216. The base of that exponent is 12. So those are the bases of your logarithms. The answer to the logarithm is the exponent. So the exponent goes on the other side. So that's 1/3. Exponent goes on the other side. That's 1/3. That's 2. And then 6 would, the only place left for it to be is there. And for this one, the only number that we haven't talked about is 144. If you want to check if you did these right, just do the wheel and see if it gives you what you started with. So if I did that, I would get 216 to the 1/3 equals 6, which is what you started with, so that you know your logarithm is accurate. Again, when you write the logarithm, write everything but the base if you're having trouble writing it. So it's just like log of 6 is equal to 1/3. But you do have a base, and that base needs to be a subscript. Okay, so it needs to be underneath a little bit. This one will be log base 12 of 144 is equal to 2. That's all for the practice chapter 5 quiz.